In this video, we'll be looking at classifying the real numbers. The real number system is used to help organize numbers into different classifications based on their characteristics. We say real numbers because we do have a small set of numbers called imaginary numbers. We will cover that in later math classes, starting with Algebra 2. The real number system can be thought of as a target on a blank wall. There's two different parts. So the entire white background, this area right in here, is known as the real numbers. Now, the reason why I say target is the most precise number, which happens to be the center of the target, the bullseye, right there, is our most precise number, and that would be the natural or counting numbers. And those numbers start with 1, 2, 3, 4, and so on and so forth. That is the most precise. The next layer of numbers we have are known as the whole numbers. Whole numbers differ from natural or the counting numbers in the fact that they start at 0, 1, 2, 3, 4, and continue on. After our whole numbers, we come to the next layer, which is the integers. Integers take the whole numbers and their opposite. So we'd have a -3. We'd have -2, -1, 0, 1, 2, and 3, and so on and so forth. Those are the numbers that you have that deal with the additive inverse, the opposite number of a whole number. Now, the least precise number in this target system would be known as the rational numbers. Rational numbers include any number that can be written in the form of a fraction, where we have a over b, and a and b are integers. B is never equal to 0 because you cannot have 0 in the denominator of a fraction. But this is going to be numbers such as 3/4, 5/3, but also because 3/4 could be written as a decimal, you get 0.75. 5/3 is 1.6 repeating. Rational numbers also include decimals that terminate or that end, such as 0.75, and rational numbers that go on forever, or decimals that go on forever, such as 1.6 repeating. Over to the side of rational numbers, we have our irrational numbers in this circle right here. These would be our irrational numbers. The irrational numbers are numbers such as pi, square root of 5, square root of 7, because the square root of 5 does not exist as a perfect square. When you do the square root of 5, you get a decimal that goes on forever and ever and ever. So irrational numbers are numbers that do not terminate, that do not end. That is our real number system. Now, you might be wondering, what is this little box up here off to the side of the real numbers? That little box represents a very small classification of numbers that I already mentioned once before, that you'll learn about in sequential math classes, primarily in Algebra 2, and this is our imaginary. Imaginary numbers. Numbers that really don't exist, but mathematicians needed to find a way to work with those numbers, so they made up a special category for them, and they're called imaginary. So let's take a look at a few numbers and be able to classify them by their classification. Square root of 5 is an irrational. Number 9, if we list just the most precise, it would be counting or whole. But because it's a counting number, or not whole, it would have been natural. So counting or natural number, it's a whole number, which is also an integer, which is also rational. But the counting number, or the natural number, is the most precise, but it is in every single category. 3/4 is a rational. It's a rational number. 2, again, is the same as 9 with a counting or natural. 8/4. First look at that and you say, it's a rational, it's a fraction. But is it a simplified fraction? Can we reduce that fraction? What is 8 divided by 4? Well, that moves us into 2. Oh, look at that, 2. That moves us back up to there, so that could be considered a counting or natural number because it can be simplified to a more precise number. Which brings us to the square root of 81. A square root, if it has a perfect square, is a rational number, but because the square root of 81 equals 9, this also becomes a counting or natural number. What about negative square root of 16? Because I'm looking for, when I do the square root of a number, I'm looking for the principal square root, that is the positive number of the square root. I'm looking at, this could simplify to be negative 4. Negative 4 is an integer. Now, let's look at the last number. Square root of negative 16. Do you notice the difference between these two? The difference is we have a negative here, or we have the negative on the inside. When we have a negative on the inside, there is no real solution. This is how you get those imaginary numbers that you will learn more about later. But they are there, so it's helpful for you to at least understand what's out there. And that concludes the lesson on real numbers. You've got either rational numbers that could be an integer, a whole number, or a natural number, or you have irrational numbers that are decimals that do not end or terminate. They go on forever and ever, such as pi or the square root of 2. Thanks for watching, and we'll see you later. Bye.